Good everybody, Mastermind here again. So today's topic is on nomenclature of alkanes. Now, why you pack nomenclature of alkanes? The first thing you actually need to do is to know the rules of IUPAC nomenclature. Well, there's another video of mine that has just the rules of IUPAC nomenclature of alkanes. So check my bio, you'll see the link, the videos, you'll see the link to the video on YouTube. So today we just want to name some alkanes and then I'll give you some practice questions that you can do. Before we go into the structures, alkanes can be drawn using three major patterns or three major ways. It can be drawn using open chain, or what we call the Fisher structure. The Fisher, that's when you show all the bonds and all the atoms in the bond. We have the condensed form. The condensed form, that's when you only show the atoms in the structure, but you don't show the bond. And then we have the skeletal form. Skeletal form, which just shows lines. So some people call this line form. By the way, line form, which is just a line that shows the bonds in the structure, not showing any of the atoms that are present in the structure. So in this video, we will just be doing majorly on the open chain and the condensed form. In another video, we'll go to this skeletal form, which is much more advanced in university system or for university system. You can cut it. All right. So here we have three alkane structures that we are to name. Here we have the open chain form, which I call the Fisher form. Another open chain form, which I call the Fisher form, and we have the condensed form, which is another form of drawing alkanes. Now, the first thing you do when you want to name an alkane, following IUPAC rule, is locate the longest continuous carbon chain. Now, you need to be very careful, not just long chain. It has to be the longest chain, has to be the longest, not just the longest chain, it has to be the longest continuous carbon chain. And now, as you can see, the longest continuous carbon chain here has how many carbon? Let's count from left to right. We have 1, 2, 3, 4, 5, 6 as the longest continuous carbon chain. We have 6 carbon in this structure. And if you look at this structure very well, there's all the atoms here are either carbon or hydrogen. And there's one unique thing about alkane in one of the videos I've made, that alkanes, they are hydrocarbons. Naturally, they should only contain hydrogen and carbon. So any other thing that there's no hydrogen and carbon here is termed a substituent group or a substitution. So since there's nothing here that is carbon, that is not carbon and hydrogen, so we agree with Steven that there is no substitution in this structure, hence there is no substituent group. So as a result, the longest chain here is just 6 carbon, and also in one of my videos I've taught you the parent name of alkane, and the parent name of a 6 carbon alkane is called hexane. Hexane, with the molecular formula which I've given you, which is around, I think, C6 H16 or something. Yeah. So H18. This is H18. Okay. So, but if you want to see how the molecular formula is done for the alkanes, can watch that on my YouTube page and you understand it better. It's very, very much explained there. Now, in structure B, we have for structure B, we have also a Fisher structure, and here, as usual, the first thing we'll do is to locate the longest continuous carbon chain, either from left to right or right to left. So let's pick from left to right. So we have, sorry, let me complete this. This should be hydrogen, hydrogen, and hydrogen. Okay. Now from left to right, we have how many carbon? We have 1, 2, 3, 4, 5, 6, 7. So we have 7 carbons from left to right, or 7 carbons in the longest continuous chain. Now, if you notice here, in this structure, we have atoms that are not hydrogen or carbon. For example, we have chlorine here and we have bromine here. Those atoms are called substituent group, or what we just call substitution. And now, how do you take care of it? Now, part of the IUPAC rule is that substituent group on an alkane must be given the least possible number, either from left to right or right to left. Now, I have a style that I usually like using to teach students on how to get a particular portion, a particular part to follow. Now, you know we have two parts here. We have the left part and the right part. You can either count from left to right or count from right to left. So the first thing I would advise you, label your structure. You have the left part of the structure and we have the right part of the structure. Now, there's somewhere in your book. Now, we want to get the least possible number for each of the substituents, or for all the substituent group, either from left to right or right to left. Now, from left to right, let's count. What carbon is the chlorine and the bromine found from left to right? So from left to right, we have 1, 2, 3. The chlorine is on carbon 3, so you write it out. Carbon 3, which shows the carbon that the chlorine is attached to. That's from left to right. And then moving on, we have 4, 5, 6. The bromine is attached to carbon 6. So what you do is you add that 6 to this 3. That will be 3 plus 6. That gives you a sum of 9. So from left to right, the substituent group have the least possible number of 9. Now you repeat the same thing, but now from right to left. Now from right to left. Now let's count. We have 1, 2. The bromine is on carbon 2 coming from the right side. Bromine is on carbon, so we have 1, 2. Then write it out. 2. And then we have 3, 4, 5. Now 2 plus, the chlorine is on carbon 5. So write it out. 2 plus 5. That gives you 7. So if you check, the number that the substituent group have from right to left is smaller than the number from left to right. So we pick the parts that give the substituent group their least possible number. So we count from right to left. So let me now number the chain. Please always make sure you know the paths to follow before you number the chain. It makes your work very, very easy. So let's number. We have 1, 2, 3, 4, 5, 6, and 7. So now it's time to name it. Part of IUPAC rule is that substituent group must be named in alphabetical order. Now we have a bromine substitution and a chlorine substitution. Based on the alphabet order, B comes before C. So, and we use hyphen to separate the number to which the substituent group is attached and its name. What I mean is that we use hyphen to separate number and alphabet. So let's name together. Name with me. So starting from bromine, I'm attached to carbon 2. It's going to be 2-bromo. See, I use an hyphen to separate numbers from alphabets. Now 2-bromo. Now we're going to the next substitution, which is on carbon 5 for chlorine. Then use another hyphen to separate it. Hyphen separating alphabet and number. 5, then chloro. Is there any other attachments again? I don't think so. And then we have 7 carbon. 7 carbon, the parent name is what? Heptane. So 2-bromo, 5-chloro, heptane. That is the. Some everybody might decide to put this as an alphabet and capital letter, but it doesn't really matter. You can put yours as small letter, you can put yours as capital letter, it doesn't really matter. As the parent's name. Alright. Now for the last one, which is this condensed form. Now for beginners, I will always advise you to convert this condensed form to the Fisher form, so you can make your work easy or make your work easier. So the first thing I like doing is take it from, I know you can take it from right to left, but I'll prefer left to right. So let's take it from left to right. From left to right, the first carbon term we have there is CH3. Each carbon is a term. So the first carbon term we have is CH3. So let's draw it out. We have CH3. 3. Now there's something you need to know about organic chemistry. There's no order. You can start writing your own H from down. Just make sure that the bonds are correct, that the bonds are attached to carbon, which is what is important. So we have picked the first term. Now let's pick the second term. I think this is overdue. Sorry, this is overdue. This should just be 1 chlorine. Sorry, just be 1 chlorine. 1 chlorine. Because carbon is tetravalent. So it has one bond to this carbon. It has another bond to hydrogen. It has another bond to chlorine, and it has another bond to this carbon. So that's an honest omission. Sorry. So now the second term we have here is CHCl. Okay, I told you every carbon is a term. So a bond from this carbon to this carbon is this bond. Then we have C. Now you can decide to put your own H down, but maybe I'll put one up. CH, and then this chlorine Cl. So we are done with this term. So the next term we are going to be interested in is this term, which is CH2. There is a bond between this carbon and this carbon. We have CH2. And then the next thing we'll do is CH2. So we have CH2, right? And we have CH2. And we have CH2. And then the last atom is iodine, which is I. So this is the open chain form of this condensed structure. So next we'll go ahead to name it. As usual, the first rule is locate the longest continuous carbon chain from left to right first. So how many carbon is found in this chain? What is the longest continuous carbon chain on this structure? So we can count. This is the carbon. So we have 1, 2, 3, 4, 5. So we have 5 carbons in this structure. So the next thing we have to determine what path should we follow to number the structure. Should we follow left to right or right to left? So as usual, I always ask you to label it to determine the path before you number the chain. So this is left part of this chain, and this is the right part. So as usual, we can use here. Now let's count from left to right. By the way, the substitution here is this chlorine and this iodine or iodine, because they are not carbon or hydrogen, so they are substituent groups. So from left to right, that is somewhere left to right. Now from left to right, what carbon does this chlorine has? We have 1, 2 on carbon 2. So we write it somewhere. Carbon right 2. Then let's get the carbon to which this iodine is attached to. So we have this is 1, 2, 3, 4, 5. So the iodine is attached to carbon 5. So to be 2 plus 5, this gives you a sum of what? 7. And then from right to left. From right to left. Now from right to left, let's see the carbon to which the iodine and chlorine is attached to. Right, from right to left, we have 1. This iodine is on carbon 1, so we have 1. And then we have 2, 3, 4. 2, 3, 4, which is 1. That's 4. That's 1 plus 4, which gives you us a sum of 5. So as you can see, from left to right, the sum is 7, and from right to left, the sum is 5. So an IUPAC rule says that we must choose the path left to right, or right to left, that gives the substituent group their least possible number. So we must choose right to left. So we have to number right to left. So we number 1, 2, 3, 4, 5. Please understand the reason why we have to number right to left. We are doing that because right to left, the substituent group have their least possible number. So the next thing is to name it using IUPAC rule. And IUPAC rule says that substituent group must be named using alphabetical orders. So we have chlorine and we have iodine here. So based on the alphabet, C comes before I. So the name of this structure is going to be, I'll write it under it, starting from chlorine, attached to carbon 4. We have 4 chloro, 4 chloro. So we are done with this chlorine. The next thing we're going into is iodine. It's on 1. Always do not forget, you always use hyphen to separate numbers and alphabet. And then you don't separate alphabet from each other. You don't need to separate them. Just write it beside yourself. So we have iodine number 1. We have 1. By the way, iodine is on hydrocarbon chain. Iodine is called iodo. So it's going to be IODO. Iodo. And then that's all. And then the next thing is the 5 carbon, which is 1, 2, 3, 4, 5. The parent name for 5 carbon is called pentane. It's called pentane. Pentane. So this is about the names of the structure. So I'll give 2 practice questions. Feel free to comment your answers in the comment section, and then share and engage this video. All right. So these are 2 lovely alkane structures that I want to name. This is in fisher form and this is in the condensed form. Feel free to drop the name in the comment section. And if you don't understand how to name this, the video is on my YouTube page, M Sciences. Full video on the nomenclature of alkane, the rules, and how you can do it. So that's about it. So thank you for your time. Thank you for your patience. Thank you for watching this video. I remain Mastermind of Mastermind Tutorial. Let's see.